Hey guys, this is Jake. Today I'm going to be giving you a walkthrough of part 2 to our SJU ACM Clue series, this time titled An Incident in the Cloud. So let's get started. So this time around, the incident reads, the day is Wednesday, April 17th. The St. John's ACM Student Chapter eBoard is collaborating on their cloud platform to design a new workshop for their members. Upon logging in, they're met with an alert in their SIEM indicating that one of their workstations may have been infected with malware. The alert shows that a mysterious command was run on David's workstation. However, David claims that he was not logged in to his workstation at the time of the alert and suspects that someone else on the eBoard must have been the one behind this incident. The members of SJU ACM have agreed to investigate the alert in hopes of uncovering the true identity of the culprit. It's up to you to figure out who did it, where they did it, and what malware they used. Similar to last time, our suspects are all of the members of the SJU ACM eBoard, and all of the buildings are the same. As we'll see, this time the buildings are separated based on subnets in the cloud environment that we'll be able to work with. And all 6 malware options are the same as last time as well. So now jumping into the Azure environment that we've been given access to, we can see that we have access to a resource group right here titled ACM Cloud Resource Group. Now we can also head to the top bar right here, and we're going to start off looking in Microsoft Sentinel where the incident was produced. Now in Sentinel we can see this one incident that was produced, and we can take a bit of a closer look at it right here by clicking View Full Details. In this alert, we can see that a process was executed from a binary hidden in a base64 encoded file. And looking a little bit more into the description right here, we can see that this involves command line arguments where it detects base64 decoding taking place. Now, what we can do from this screen to look into it a little bit further is we can click on this Events button right here. Clicking on this button will open up the actual log that was captured off on the right-hand side. Clicking a little bit deeper into this log, we can see right here this command line field. And very easily we can see base64 right there. And it looks like this whole blob of text is what is being decoded by this line of code. So now what we can do is we can actually copy this chunk of text, and now we can open a new tab to CyberChef, a really helpful tool for manipulating any data that you might have. And so right here on the left, we see that we have an option for from base64. And now all we have to do is paste that chunk of text into the input box. And now we can see the decoded command right here. So a few things here. We can see that it's performing an invoke web request on this URI. So basically what that's doing is it's downloading this GitHub repository for itself. And looking at the name of this GitHub repository, we can see that this is a Python keylogger that we're dealing with. With a very simple Google search, we can find that a keylogger is indeed a type of spyware. And just like that, we've found out what type of malware was used. Going back to the decoded command right here, we can also see a bonus question, and we will revisit this a little bit later on. Now back in Azure, we're going to close all of this out, say done. And the next thing we want to work on is figuring out where this happened. We know that it happened to David and on David's workstation. So let's take a look at these entities that we see over to the left-hand side. And we're going to click on David's workstation. Clicking into David's workstation, we get a little bit of some info here on the right-hand side. And a couple of things stick out to us. First, we can see that he has a private IP address of 10.0.2.4, And scrolling down a little bit more, we can even see the virtual network / subnet that he belongs to, and that would be Marillac. So just like that, we've found out where the incident occurred, and that is Marillac. Another way of looking at this is if we were able to find this IP address, we can navigate to virtual networks within Azure, click into the ACM VNet right here, and then we can go down to subnets right here, and we can see all of the different subnets that were created. And since David had a IP address of 10.0.2.4, we can correlate that to the subnet of Marillac. Back in Sentinel now, we can begin working on figuring out who performed this incident. Now, we were briefed that David claims that he was not logged into his machine at the time of the incident. The time of the incident being 6:52 p.m. on Wednesday, April 17th. Knowing that, we can start digging a little bit deeper into figuring out who was actually logged into the machine at this time. So in order to do that, we can go to the Logs tab on the left side right here. We can clear the query that might already be there and open up this left panel here. Click into Microsoft Sentinel, and we want to look at the security events. This is going to show us all of the logs of all security events taking place on all of these Windows workstations. One of the things collected by security events in Windows is login attempts. And so if we scroll over to the side right here, we can see that there are indeed logs indicating when an account was successfully logged on. So we want to filter all of these logs by that. So if we click on this column right here, the 3 dots over to the right, and we only select these logs right here, where an account was successfully logged on, that will filter all of our logs to only include those of successful login attempts. However, we can filter these logs down even further since we're only looking for login attempts on David's workstation. So if we go to the computer column right here, we can also filter here only by David's workstation. And just like that, our list of logs is significantly shorter than what we previously started with. Looking into some of these logs now, some of these are just normal kind of service accounts performing some sort of action on the machine. And so because of that, we really want to look at these user account types right here. Digging into this log a little bit more, we can find a couple of things that are interesting. First, we see that the IP address used to log into the machine is different than the IP address that David's workstation has, as we saw previously. So that's pretty interesting. Scrolling down a little bit farther, we can actually see the workstation name that attempted to log in to David's workstation and was able to successfully log into the workstation. And that workstation belongs to Feiruz. So this evidence right here points towards Feiruz being our culprit. Another way we can look at this is taking this IP address, once again going to virtual networks, going into the ACM VNet, and looking at the connected devices, and we can correlate that 10.0.6.4 IP address also to Feiruz's workstation. So there we have it. We figured out who did it, where they did it, and what malware they used to do it. But now we're going to look into a bit of a bonus question here. So going back to that base 64 encoded command here, we can see our bonus question. So after discovering that David's workstation might have been infected with malware, investigators ran a packet capture via Azure to analyze network traffic originating from the infected machine. This packet capture can be downloaded from Network Watcher Packet Capture. Can you find the password that was captured and shared with the attacker via this keylogger? So we want to do a couple of things in order to solve this question. The first thing is we want to actually look at this code for this Python keylogger. So navigating to the GitHub repository for this keylogger, we can look into the keylogger.py file. Skimming through this code a little bit here, we can see that it clarifies an IP address and a port number on port 8080, which is commonly used as for HTTP. And also we have a method here for sending a post request in the form of a JSON object to this IP address using port 8080 over HTTP. Back in Azure, we can navigate ourselves to Network Watcher and go to the Packet Capture tab. And right here we can see a packet capture that was performed on David's workstation. So if we click on it, and we were supposed to be able to click on this link right here to allow us to download it, but unfortunately we didn't have the proper access set up for that. It's no big deal. I already have it downloaded, so we're going to take a look at it. So here we are in Wireshark, and as we can see, this packet capture is quite large, has a lot of traffic in here. So what we're going to want to do is we're going to have to filter it down quite a bit. And so the first thing we can filter it down by is the source IP. We know that the information is being sent from David's workstation to Feiruz's workstation. So what we can do is we can use ip.source up here in the filtering bar and set that equal to David's IP, which is 10.0.2.4. Pressing enter will show us all of the traffic originating from David's IP. Now we can set the destination IP to Feiruz's IP address using a double and sign and do ip.dst for destination and set that equal to Feiruz's IP, which is 10.0.6.4. Now we see all the traffic originating from David's IP to Feiruz's IP, but we still have quite a bit of traffic here that we would like to filter down even more. And so since we know that the information is being sent over HTTP, we can filter it by HTTP packets using a double and sign again and just putting HTTP. Now we're just left with a few packets here, much more filtered down, and we can indeed see that they are HTTP and they are all post requests in JSON notation, as expected, as we saw looking into the source code for the keylogger. Looking a little bit deeper into the packets, we can see that in the JavaScript object notation field, there is a keyboard data object. In this packet in particular, since this is the first one, the string value is empty, but if we go down into the next few, we see that this next one captured ACM, and the next one captured even more with ACM is awesome 24. And if we look into the ones after that, it's all the same. And so it seems like the password that was captured from David's workstation is ACM is awesome 24. So there we have it. You solved the mystery. Feiruz was our culprit. She performed the incident in Marillac, and the malware she used was spyware. Additionally, our bonus question, the password captured from David's workstation was ACM is awesome 24. Thanks for following along. I hope this was helpful and you enjoyed this little lab activity. If you're interested in learning more about how I set up this environment and some of the planning that went behind it, I am going to be coming out with another video after this one that you can definitely check out and learn a little bit more about how I set up the whole environment in Azure. Thanks again, and we will see you next time.